Alright, so today's lesson is going to be 8.2, which is going to be on geometric sequences. So a geometric sequence is a sequence found by multiplying a constant number to the previous term, and that number can be negative. And when that number is negative, it's going to alternate between negative and positive terms in the sequence. So how do you find what we call the common ratio? That's the term that would be repetitively multiplied, kind of like the common difference in arithmetic. Is you would basically take the second term and divide it by the first term. Now, in order to check if a sequence is geometric, you want to make sure that pattern is consistent throughout the entire sequence, the portion of the sequence given to you. So for number 1, what we're going to do is we're going to look at what's happening here. So what happens from 3 to 6?
It's doubled.
Multiplied by 2. And then is that consistent for the next one?
Yes. Yeah.
So is this geometric?
Yeah.
Yes, and its common ratio is?
2.
Okay. So for the next one, how can we get from 1 to 5?
Multiplying by 5, or I guess adding 5.
Not adding 5, but adding 4. Hi. Okay. So anyways, where was I? So yeah. So see how here we add 4, and then we would add 4 again, and so on. And you see how that pattern is consistent? It is a sequence, but what kind of sequence is it?
Arithmetic.
Good. So it's not geometric. Therefore, there is no common ratio. It would have a common difference. See the difference between the two?
Well, I was going to say
Well, they do all have common denominators of 1. So, okay. So analyze the finite geometric sequence and graph the first 6 terms. So in this question, what we're going to do is we're going to determine what the common ratio is. So here's the thing. In this problem, they tell you it's a geometric sequence, so I can automatically assume that there is some pattern. Okay? So since they tell me that, I can assume a pattern. So how you find out what that pattern is you take this second term and divide it by the first term. Now, as you can see, 9 does not go into 6, but can I reduce this fraction?
Yeah.
What would this reduce to?
2 over 3.
So the common ratio here is 2/3. Okay. So what I can now do is I can apply this common ratio to the following questions. All right. Or the following terms. So I would take 4 and multiply it by 2/3. So 4 over 1 times 2 over 3 is 8 over 3, right? And then 8 over 3 times 2 over 3 is 16 over 9, right? And 16 over 9 times 2/3 is just 32 over 27. So I just multiply the top and the bottom by that fraction. So now I have some terms. So we want to identify the domain and range. So similarly, it is finite. So domain is the position of the term. So position 1, position 2, and so on. So there's 7 positions, right? And can you remind me what the range is?
That's the numbers that are there.
Yeah, the actual numbers themselves. And when we go ahead and graph this, we're going to have to get some decimal approximations for those fractions. So I'm going to put these fractions into the calculator. So 8 divided by 3 is approximately 2.7. 16 divided by 9 is approximately 1.8. And 32 divided by 1.2, yeah. So those are just decimal approximations I can use to graph it. So now I'm going to go ahead and graph the first 6 terms. So what's my first term again?
9.
Good. What's my second term?
6.
My third term?
4.
And then 2.7. And then we have 1.8. and then 1.2. So it has this type of shape to it. Anyone recognize this shape?
Looks like a
Exponential, very good. Exponential. Is this exponential decay or exponential growth?
Decay.
Decay. So geometric sequences are exponential functions because each successive term increases or decreases by a constant factor called the common ratio. So your common ratio is basically your, when we did exponentials like the b, okay? It's that number to the power. So yeah, geometric model exponential, arithmetic model linear. All right. So just like with arithmetic, we have explicit and recursive rule. And here's the formula. The main difference is that we use r instead of d, and it's multiplied instead of added. So we're gonna, yes.
What was the second word? It was decreases by a constant factor called the like
Common ratio. All right. Does anyone have any questions about this right here? All right. So let's go ahead and try to apply the formula. So write an explicit rule in simplest form and a recursive rule, and then find the sixth term. So I'm going to zoom in here, okay? So they tell me that these are geometric sequences. So to find the common ratio, I'm going to take the second term divided by the first term, and what is this going to reduce to? 1/3, right? You all see why that is? So this one has an r of 1/3. So the explicit rule is just going to be a sub n is equal to your first term times your common ratio to the power of n minus 1. The recursive rule, you only have to change one thing. So you write out what the recursive rule is. A sub n is equal to a sub n minus 1 times whatever your common ratio is. So every recursive rule will look exactly the same except for the common ratio. Okay? Now, as for finding the sixth term, which formula are we going to use for that? Explicit or recursive?
Explicit.
Explicit. Very good. So I'm going to take my n and I'm going to plug it in for, or I'm going to plug 6 in for n. So everyone see what I did there. I plugged in 6 for n. And if you do this math out, it's going to give you 4/27. So if you kept going, so this is the first term, second term, third term, fourth, fifth, and sixth. If you kept multiplying by 1/3 over and over again, you would eventually get to 4/27. Okay? Yeah, because this would be 4/3, and this would be 4/9, and then it would be 4/27. Okay. So this one you might be able to just visually see what the common ratio is. Any ideas?
Yeah.
Very good. So you're going to notice that when your common ratio is negative, those terms are going to alternate between positive, negative, because multiplying a negative by a negative, then a negative by a positive is going to alternate the sign, right? So your explicit rule is going to be a sub n is equal to your first term times the common ratio to the power of n minus 1. Your recursive rule is always going to be a sub n is equal to a sub n minus 1 times the common ratio. Alright, and then we're going to plug in for n, so we're going to be plugging in 6. So if you do that math, you do the exponent first, then the multiplication. That gives you negative 3,027. Any questions?
It's 73. It's n minus 1, so it'll be 6.
6 minus 1.
What are we trying to find?
A of 6.
Oh.
You see it?
Yep.
Okay. Oh, it's 72? Let me try it.
I don't think, yeah, I think because.
You're right, it is 72. I wrote it backwards on my key. My apologies. Thank you. Negative 3,072. Sorry about that. Okay. So, state the missing terms in the following geometric sequence. So you remember we did this with arithmetic and I taught you that little rule? I'm going to teach you a new rule for geometric, okay? So here's the rule. You take the last minus the first. And when I say last and first, I mean those that are directly next to the space, okay? Oh, I'm sorry. I'm writing it like geometric. I mean arithmetic. That's my apologies. You take the last divided by the first, because we're reversing multiplication here. And then you put this to the power of 1 over the number of spaces plus 1. Okay? That's the formula for R. Similar to the, the D, but it's a little different because it's division. So let's go ahead and try it out. So R is equal to 80 over 45 to the power of 1 over 2. So R is equal to 4/3, which in the calculator is going to be like 1.3333 repeating. So now that we know what R is, how can we apply it to get the next term? Exactly, you're going to multiply it by 45. So 4/3 times 45 over 1, that's going to be 180 divided by 3, which is 60. So we have any questions about that? Do you all understand why the formula has to be different for common ratio versus common difference? Okay. Oh, sorry. So next one, how are we going to set up to find the common ratio?
It's 12 over 972 to the power of 4.
Good, to the power of 1 over 4. Everybody understand where the 4 came from? Number of spaces plus 1.
1.
Good. So, do this in my calculator. Good, 1/3. So to apply the 1/3, we're going to multiply, bathroom? Yeah, just sign out, each of these. So this is going to be 3/24. I multiply that by 1/3 or divide it by 3 and I get this. I do it again and I get this, and then if I do it again I get 12. So that's the common ratio. Any questions about that?
Sorry, can we go back to the
Yeah, that's fine. I can actually zoom out so you can all see it. That works. There we go. So don't forget different formulas for common ratio and common difference, because they are different things.
What is the 180 over 4?
Right here?
Yeah.
Oh, because 4 times 45 is 180. 3 times 1 is 3.
Oh, and that's how you got 60.
Yes.
Oh, okay.
Yep, I'm just multiplying, and I'm just showing you how I take 4/3 of 45. I put them over 1 so then I can multiply across. Okay? All right. We good to move on, or? Okay. All right, so this one says a ball's height on consecutive bounces forms a geometric sequence where the heights or what are the heights of the second, fourth, and fifth bounces? So you know how if you let a ball, like a basketball, go and it starts like bouncing off on its own, you know how it like slowly gets like closer and closer to the ground? It does that in a geometric pattern, exponential decay of the height of the bounce. So we're going to actually calculate that. Now, this is where people get really confused by the number of spaces. When I talk about number of spaces, I'm talking about number of spaces between the two pieces of information we have, okay? So how would I go ahead and set up finding my common ratio here? Any ideas?
49 divided by 100.
Good. 49 divided by 100 to the power of 1 over 2. So does everybody see why it's 2? The number of spaces between those two numbers plus 1. So even though there's these spaces, what we can do is we're not using that right now. We're just looking at, like, we're not looking at this portion. I'm covering it with my hand like you can see my computer screen. We're not using this right here. We're just looking at this first. So if I do that math, R is going to come out to be 0.7. So how can I apply 0.7?
We multiply by 100, like,
Good.
70.
70 cm. Good. So this is A1, this is A2, that's 70, this is A3. How can I now find A4 and A5?
Multiply is 49 by 0.7.
Good. And that's going to come out to be, I think, 34.3, right?
Yeah.
And then I think the last one came out to be 24.01 cm, if I remember correctly. Yeah. All right. Any questions about that? What do you think about geometric?
Pretty good.
Pretty good. A lot of people will say it's harder than